now we want to turn our attention to the inverse trig functions. And in particular, we want to look at inverse sine, inverse cosine, and inverse tangent. And we'll start off with inverse sine. Now recall the graph of sine looks like this. If we are graphing from negative 2 pi to 2 pi, remember the domain of sine goes, it's all real numbers, negative infinity to infinity, but the range goes from negative 1 to 1. Now one of the things in the context of talking about inverses you'll notice about this function is it's not 1 to 1. It fails the horizontal line test. However, our discussion doesn't need to end there, because remember, one of the things we can do if we want to talk about the inverse of a function that's not 1 to 1, we can limit the domain of the function and talk about the function having an inverse on an interval where it is 1 to 1. And for the case of sine, that would be here between negative pi over 2 and pi over 2. So when we talk about inverse sine, we're going to refer back to the sine function and limit the domain to be between negative pi over 2 and positive pi over 2. Now, you see when I expand that, this part of the function is 1 to 1. So this is the graph of sine between negative pi over 2 and pi over 2, and it definitely passes the horizontal line test. And this is what the graph of inverse sine would look like. Notice that the graph of sine goes from negative 1 to 1 for the range. Well, the domain of inverse sine will go from negative 1 to 1. And we were looking at the domain for sine to go from negative pi over 2 to pi over 2, so that will be our range for the inverse. For the inverse sine, we're going from negative pi over 2 to positive pi over 2. Now, just some summary information. As was illustrated with the graph, the domain is negative 1 to 1. And the range will be negative pi over 2 to pi over 2. In other words, you can see that whenever you put in a number between negative 1 and 1, if that's the input, the output for inverse sine is always going to be in quadrant 1 or 2. You're going to get output ranging between negative pi over 2 and pi over 2. So that's something we want to keep in mind when we're talking about inverse sine. Inverse sine will only output values between negative pi over 2 and pi over 2. Now let's turn our attention to inverse cosine. And once again, we'll look at the graph of cosine. And like with sine, you'll notice that this is not a 1-to-1 function. So we limit the domain. This time we'll say, well, we'll limit the domain from 0 to pi and just talk about that interval from 0 to pi. That will be the interval that we use to derive the inverse cosine. So expanding that, we get this graph, which is definitely 1 to 1. Notice from 0 to pi. The inverse cosine would have as the domain negative 1 to 1. And the range would be 0 to pi. Now, we've already stated the domain is negative 1 to 1. The range then would be 0 to pi, and that would put us in the first and second quadrants. So, with inverse cosine, we always input values between negative 1 and 1 inclusive, and it will output values between 0 and pi inclusive. Now on to inverse tangent, and recall this is the graph of tangent going from negative 2 pi to 2 pi. And once again, fails the horizontal line test, so we limit our domain to go from negative pi over 2 to pi over 2. So this is the part that we will use to define inverse tangent. Expanding that, we get this graph, which is definitely 1 to 1. And you can see that we're going from negative pi over 2 to pi over 2. And of course, the range goes from negative infinity to infinity for tangent. Now, the graph of the inverse tangent would look like this. Notice that we're going to have an asymptote, a horizontal asymptote. Just like with tangent, we have vertical asymptotes at negative pi over 2 and pi over 2. Well, with inverse tangent, we have horizontal asymptotes at negative pi over 2 and pi over 2. And, of course, the domain will be negative infinity to infinity, the range negative pi over 2 to positive pi over 2. So here we have the domain negative infinity to infinity. All real numbers can be inputted into tangent, inverse tangent. The output, like with sine, we're going to have output between negative pi over 2 and pi over 2. Output will be in the first and fourth quadrants. Now, to summarize, inverse sine, domain, negative 1 to 1, range negative pi over 2 to pi over 2. For inverse cosine, same domain, negative 1 to 1, output, though, 0 to pi. And for tangent, negative infinity to infinity for input, domain, all real numbers. Output, negative pi over 2 to pi over 2.